Awesome. Hello, everyone. Great to see many of you here. There are some seats at the front if you guys want to come and sit down. So first of all, I want to thank you all for coming here. I don't know if many of you know, but we originally tried to organize this event in Miami at about the same time, in February, and we thought, people will have a great time, go to somewhere warm. We had a few amazing speakers lined up, the venue was booked, and then you know what happened? Well, none of you signed up, okay? So it's actually great to see all of you here in Denver, building in the bare winter with a lot of other folks, so I'm excited for this. Awesome. So before we talk about Axelar, I want to take just a quick step back and tell you a little bit about why we're here and what are we really trying to do, right? I think many people have made the analogies that blockchains are really cities, right? They're powered by unique technologies, they're open, they're permissionless, and they need to be robust, right? So whether or not you're talking about a natural disaster or kind of government or electricity going down, the cities need to continue functioning. So the question is, how do you build a business across all of these cities at the same time? So if you're building an NFT store or you're building a stable coin, you want to be able to give users a very simple way to access your business and interact with it in a consistent and uniform way. And so until recently, we only had two options. Right? The first option is what we call the trust option, and I think we've talked about it throughout today. Right? It's not that hard to take a centralized database and build it across decentralized cities. Okay? You put a server, you put an application server in the middle, and that's it. But we've seen a systematic failure of a lot of these centralized protocols. And the second option is what I call the suffering option. Okay? What does it mean? Well, as a developer, right, you can go and take your application and you can put it across all of these different chains. You can clone it, right? Like Uniswap's been doing it or USDC's been doing it. But then you leave it up to the users to figure out how to use the application, right? And it's up to the users to get a wallet, get some gas, and we talked about it today, figure out how to bridge their tokens back and forth. And it's really, really bad experience for the users at the end of the day. And we cannot continue scaling that way. And so today, there is a better way, right? And the better way is to build interchain native applications. So these applications are architected from the ground up in a different way. They're relying on different technologies and have different properties underneath the hood. So these interchain native applications can span the whole of Web3. So meaning that whether or not you're using this application in one city or the other, you would have a consistent and uniform environment and consistent user experience that you can offer to your users. They can be powered by decentralized interoperability protocols, right? We have an array of protocols that have been built. They're all can be robust. They can all stand the test of time and all kinds of nuclear and other types of disasters that you can think about. They allow your applications to compose, right, from one another. So sending smart contract calls, transferring tokens, messages back and forth. And at the end of the day, they enable very, very simple user experiences. And this is what we want. So if you haven't played with any of these interchain native applications, I think you just heard a panel by kind of a Squid and a few other folks. And I think it actually gives you a sense of what does interchain native mean, right? So to give you a sense a little bit of how this actually works under the hood, so Squid actually does not build a new DEX or anything else, but it allows you to swap an arbitrary token from one chain to an arbitrary token on another chain with one click. Right? The way that it actually does it is by, in an interesting way, composing existing DEXs and routing liquidity across them. Right? So things like USDC. So no new wrapped assets have been created in this process. Very simple UX, very simple to interact with. And you don't have to think about multiple chains as you're using this application. So go and play with it if you don't know what interchain native means. And the second point about Squid is that because it's interchain native and it's been redesigned from the ground up, the security properties that it has are actually really, really strong, meaning that it does not assume a lot of security from the underlying bridge other than in some ephemeral state while you're doing your transaction. So, and you could only do it if you actually redesign your application, you don't have wrapped assets or anything else like that. And so this is the end game of interchain native, right? It's the having simple UX, having simple composability across the applications, this is exactly what we're here for. And so from the very, very beginning, this has been Axelar's goal. I think if you look at our earliest presentations and everything, this has always been the mission. How do we enable users to interact with any asset on any application, on any chain, with one click? And the way to do this, and the way we've been doing this from the beginning, is to focus on developers. So Axelar's mission from the day one has been to empower developers to build applications that can span the whole of Web3. So if you look at our early white paper in the beginning, you can actually see that its title is Connecting Applications with Blockchain Ecosystems. We don't focus about bridging. We don't talk about how does chain A talk to chain B, but we really talk about what does the stack needs to look like, what do the architectures need to look like, so you can enable the experiences that we're talking about here today. This has been our goal, and this will always be our goal, is to think about how to help developers to build these interchain native applications. And so this is what we have done, right? On the high level, AXL network consists of 3 different layers. So the core layer, there is the network itself. It provides you connectivity. It provides you routing. It provides you message translation. And I'll talk about these things in a little bit. On top of it sits what we call as a service layer, right? So things like relayers, things like gas services, things like monitoring services, all the pieces of infrastructure that are needed to actually enable those developer experiences that we talked about earlier. And at the very top of it, very simple SDKs and APIs that we expose to developer to actually consume the rest of the stack. And so today, the AXL network, it's been live for a little over a year. We're connecting over 30 different ecosystems and 30 different chains. Packets can go in and out between any of them, processed over 1.8 billion in cross-chain volume, and working with a lot of leading partners like Circle, Osmosis, Ledger, and so on and so forth. So I'm very, very excited to where we got here today with the AXL network. So I don't want to go a little bit too technical, but let me give you a little bit of a preview of what are some of the key features of the AXL network. And the first one is a basic property to be able to connect chains in a very efficient way. Right? So at the core networking layer, there are multiple interoperability protocols that are supported. You can use IBC if you have IBC support. You can use a protocol like CGP that we developed to connect with EVM chains. All of those protocols are available at the network layer, and it depends on the chain that you're interacting with. You can use one or the other. The core property of the network is that automatically, every time you establish a connection, you get many-to-many routing properties, right? So the traffic from your connection can be routed to any of the other ecosystems and can be sent there. You can do things like asset transfers. You can do message transfers. And really, you can think about anything else to transfer across these protocols. So they're completely generic. So one of the very exciting properties that I like about the network is what I call as a cross-chain translation. And we have actually done this recently by having a stack that now can fully interoperate between Cosmos and EVM chains. So previously, we were able to transfer like tokens, and you can send assets back and forth with one another. We've done more. We've extended it so that Cosmos chains are now fully interoperable with EVM chains using things like general message passing. So you can encode your transaction in a Cosmos stack. You can send it through Axelar. We'll help you decode it and rephrase it and figure out the right encoding that it needs to happen to post it on the EVM chain and vice versa. So in some sense now, the Cosmos stack, I think, is becoming more and more glued together with the EVM stack. And I think, as time goes by, these are going to be indistinguishable ecosystems, I believe. So it is live on the testnet. It is staged for the mainnet over the coming weeks. So I'm really, really excited about this property. Now, how do actually developers consume all of this? And it's actually very simple, right? So you download the SDK, and then you can leverage any of the protocols that we have, like general message passing for token transfers, and compose your applications. You can issue interchain tokens. You can transfer NFTs, and so on and so forth. And so all the complexity of interoperability that I talked about earlier throughout all the stacks is actually hidden away by very, very simple abstractions and APIs, right? This is literally the API that you need to know of if you want to send a message from an EVM chain to another EVM chain. So 3 parameters: destination chain, contract, payload. You send it, you're done. And that's what we want. We want developers to be able to use very, very simple interfaces and abstractions. Now, we do have a challenge. The ecosystem keeps growing, right? So today we have many more layer 1s. We have many layer 2s, layer 3s. We're talking about data availability layers. And so every time you have a new layer, you introduce in a system that is going to need to talk with other systems in probably asynchronous way. You're going to need to send messages between them. You're going to need to compose them with one another. And so this is kind of growing really, really fast. The deployments are getting complicated, right? As developers are building across multiple stacks, they spend a lot of their time thinking about how to deploy their application logic. And so the interoperability infrastructure doesn't really keep up with all of these things. So can we do better? Can we actually address all of these issues and keep up with the demand for interoperability? And so to solve this, we are introducing to you a new layer in the stack, which is the Axelar virtual machine. Let me tell you a little bit what that means. The Axelar virtual machine is a Turing-complete layer that we add in the interoperability stack that allows you to code at the interoperability layer itself. Okay? So it's powered by a combination of Cosmos technology plus some consensus logic and various gadgets that we've been building over the years, and they're composed together, in an interesting way, and we can talk about it more in the technical sessions. And what that means is that anybody can program at the interoperability layer. Right? You can instantiate new connections. You can optimize the speed of transport. So maybe for some transactions, you want to take a risk and finalize them in 5 seconds. For some transactions, you need to wait for longer and finalize them in 20 seconds, 30 seconds. So you can do all of that. You can customize all those protocols. And so the VM at the interoperability layer allows us to code interchain 10 times faster. That's my claim. Okay? Now, you might be thinking, well, where does 10 actually come from? Right? Is that a real number? And I claim that it is real. So I'm actually going to prove that it's 10 times faster. And the way to do this is by combining zero-knowledge proofs with artificial intelligence. Okay? So let's go through the proof quickly. I'm kidding. We're not going to go through the proof. This is one of those things that I like doing once in a while. Kind of throw my professor hat on, get in some formulas, and it drives our marketing team nuts. So it's good to have fun. Awesome. But there are 2 points I actually want to make here. Is that because it's a programmable layer, that means that the parameter 10 really depends up to you as a developer. If you're a good developer, you can code 100 times faster. You can make connections and scale interchain. If you're just starting out, it can be 1x or 2x. So that's one point. The second point, though, if you are a builder in this room, if you are in particular raising capital, you really should figure out how to combine the words zero-knowledge proofs and artificial intelligence in your deck. Okay? Funding guaranteed, I can tell you from every investor in the room. Awesome. So moving on, I want to introduce you to a couple of kind of exciting projects that we're going to be launching with the Axelar virtual machine. The first one is specifically to help us scale the interchain by adding more connections through the stack. So what does it mean? You'll be able to use the virtual machine to code a connection to the Axelar network. You can customize its security. You can extend it as much as you like. You can use any technology that you can think of, right? Zero-knowledge proofs are available. Great. You can instantiate it. Light clients proofs are available. Great. You can plug them in. The core property, though, is that by plugging in with the Axelar network in the virtual machine, you get to amplify your work. And that's why it's called an amplifier. So what do I mean by this? A lot of these kind of technologies that you use to connect ecosystems are actually hard to build. Okay? We've been talking about light client verification across non-Cosmos chains ever since I've been in the industry, frankly, over the last 7 years, right? Those are hard things to build. Zero-knowledge proofs, they're finding a lot of momentum, and I think it's going to be great technology. It's going to power a lot of blockchain stacks, but those are hard things to build. And the problem with a lot of those things is they're not reusable, right? So if you're building a light client or zero-knowledge proof to connect two different chains, you got to repeat the same work to connect two other chains, okay? Because a lot of those technologies depend on the underlying consensus, technical stacks, and so on and so forth. And so, frankly, the issue scaling those light clients or zero-knowledge proofs was not really technological, but economical, right? You spend a year or two building one of these connections, you plug in A and B, and that's it. And you can't reuse that work, right? You have to spend it over again, 2 years of work, plug it into other chains. And so by having one-to-n connectivity properties through the Axelar stack, you get to amplify your work, right? You build once, maybe you spend 2 years of engineering work, but you get to compose with all the other connections. You get to compose with all the other ecosystems for free. So you amplify all the resources that you have spent. And so you can plug that in. And so the end goal that I think we want to see is this notion of really timeless connectivity, right? Where today we should have protocols that are used very easily to connect different ecosystems. Maybe they're based on RPC methods or some external validation. If light clients, zero knowledge, IBC, anything else is available, you should be able to go and instantiate it, right? There's no reason not to. You can continue building the best in-class individual connections to the AXL network. Once you have many of these connections, you can compose them at the application layer, right? So if you have a very low-value transfer, then you can say between Ethereum and AXL network, well, I'll trust it as long as any of these connections is good, right? As long as any of these connections verifies my packet. But if you want to have strong security and you're transferring hundreds of millions of dollars, you might want to compose them, right? And you say, I want to rely on a transfer of $100 million if ZK and an RPC or ZK and a light client validation layers independently verify this transfer. So you get to compose security at the application layer, continue building your application in a uniform way, and so I think this is really, really powerful. Now, the second product that we're going to announce is something I'm really, really excited about. And so it has this property where you can build once and run everywhere. Right? And so this is called Interchain Maestro. So what is the basic idea? I think, as I told you earlier, a lot of the builders that are now stuck in this multi-chain world, they actually don't build in the multi-chain. Okay? They spend 70–80% of their time thinking about how to build multi-chain and managing their contract deployments and managing their upgrade paths and admin commands and governance around it, but they're not actually building, right? I mean, I don't know if many of you know, but there's been a long debate or discussions that just started by Uniswap community, right, about how to do governance with Binance Smart Chain. There's a lot of discussions, there's a lot of debates, and then we try to understand a little bit what is all the fuzz is about. The fuzz is about 20 messages that need to be sent over a year, right? And so people are not actually building in the multi-chain because it's hard. It's hard to deploy, it's hard to orchestrate, it's hard to manage. And so this is what we want to make it easier with the Axelar Maestro. Right? The basic idea is that on the virtual machine that we have, we'll be having a set of template contracts and a set of services around it that you can leverage to manage your application across multiple stacks. Right? So you can set up governance commands, you can set up admin commands, you can upgrade paths, and so on and so forth. So it's really going to help developers simplify their multi-chain deployments and management. And hopefully, they're not going to be spending 70 or 80% of their time on thinking about building interchain, but actually doing and improving their application logic. So that's the hope here. So if you're familiar with products like Kubernetes, this is really kind of an analogy that I think is kind of closely resonates, where in the Kubernetes you specify your deployment configuration, right, and it will help you deploy across a variety of stacks and software layers. Awesome. And so now let me give you kind of a quick demo of what is the end user experience from a developer's perspective that we want to enable. And this is a very simple demo, but it's going to show you what types of user face or developer facing interfaces we'll want to allow. So an interchain token is something we've been working on. I think every interoperability protocol by now has this notion. It's like, how do you take a token and make it available on all chains, right? In a very efficient, very consistent way. It's all about tokenization, and this is a critical service. So let me go through this demo, and you'll be able to see it. So what do we have here? We have Avalanche contract. It's an ERC20 contract that's been deployed on the Avalanche chain. And then maybe pause here for a sec. Yeah. And so through the interchain portal, you actually get to manage this token deployment across multiple other ecosystems. So here you can see that we actually deployed a version of this contract on Binance Smart Chain, on on Polygon, and it's been registered on Avalanche. If you want to deploy it on more chains, oops, sorry, go back. Let me play this. Yeah, let's just continue playing. Can we continue playing? All right. Well, it's OK. Yeah, just keep it here. So it's a contract that's deployed, on Avalanche. Like I said, you can deploy it on multiple other chains by effectively using one button. Right? It says deploy on more chains. Can we continue playing? There we go. And you just get to specify what chains you want to deploy it on. Right? So in this case, all the chains have been connected through the Axelar stack you can pick. We're choosing just 2 for the demo, so Phantom and Cello. You specify what they are, you click, you deploy gas, and that's it, and you walk away. Right? So it's literally kind of a front end that you can build that abstracts all the complexity of managing gas fees across across different chains, figuring out how do you deploy your contracts, and anything else around it. And so all the services and the stack that we've been building over the years effectively helps you deploy the contract. And this is an interchain token, right? So these tokens can be sent back and forth across chains in a very efficient way. So they're interconnected through the Axelar messaging protocol. They, connected through the Axelar scan and all kinds of other tooling and SDKs that we have built. So this is really the end goal, right? So this is like an example of a token transfer. But the deployment and management of your application across multiple chains should be as simple as that, right? And so that's what we're going to continue working towards. Awesome. So another kind of a workshop that I want to kind of send you to, if you haven't heard about it, there's actually a pretty cool SDK that's been built on top of Axelar by the Cubist friends, and it has a similar goals, right? So the question is, how do I write my contracts in a very easy way, kind of set them up and run them across multiple chain environments, and kind of backed up with the Axelar protocol and different services underneath the hood. So they're helping you automate all of those processes in a very efficient way. So I encourage you guys to go and check it out as well. So what is the impact of all of this on the developers, right? I think, first of all, we'll be able to facilitate many more connections across the stack. You can customize your interoperability, like I said. If you're a fan of zero-knowledge proofs, light clients, or you want to customize your latency, you can do all of those things. And we want to have a minimum work to run your applications across different environments. And so that's really the goal for us. And so today, I'm happy to announce to you that in the next kind of phase of the Axelar network, we actually extended the network even further and connected many more amazing partners, right? Stellar, Base by Coinbase, Mobile Coin, Near, Shardium, Starknet, Centrifuge, ZK Sync, and a bunch of other partners been working with Axelar to extend their ecosystems to all of you, all of the developers, to make sure that you can build in this interchain native way. Awesome. So yeah, I'm not going to go through the quotes. You can take screenshots and read it offline. But yeah, super excited for the lineup and working with all of these amazing developer ecosystems. The final thing I want to mention is that we really want to supercharge interchain, right? And so to do that, I'm happy to announce kind of a separate developer grant program that we're going to be launching to help build on the Axelar virtual machine and instantiate more connections and scale the interchain. The goal here is really not to, this is not a program for kind of dApp builders. We have a lot of those already. There's an ecosystem fund and a lot of things. But if you are a protocol builder, you like cryptography, consensus, you want to understand how to make connections across different ecosystems, you want to help us build this Kubernetes for Web3 using the Axelar virtual machine, this program is for you, so I encourage you to apply. And we're going to be selecting teams and working with them very, very closely to build a lot of these functionalities. So that's all. If you want to know more, there's a link. You can go. There's a QR code. There's a blog post that dives a little bit deeper on what we're building. You can find application to the grants program. And come chat with us throughout the rest of the day and throughout the rest of the week. We are super excited to continue supercharging Interchain with all of you. So thank you all for coming.